Expand the following function in Laurent series. The function is given by e raised to z divided by z minus 1 all square with the center z is equal to 1. So the function is f of z is equal to e raised to z divided by z minus 1 all square. Now we have the center z is equal to 1 here. So that the Laurent series expansion always contain the term z minus 1. So expansion is of the form in terms of z minus 1. Now this is z. So make it as z minus 1 plus 1. So that we have z minus 1 here. Z minus 1 plus 1 is z. And this is z minus 1. Now this is e raised to x plus y. We can write it as e raised to x into e raised to y. So this is e raised to z minus 1 into e raised to 1. That is e divided by z minus 1 all square. Now take e outside. This is e raised to z minus 1. E by z minus 1 is that this is e raised to z minus 1. We have the expansion of exponential function. E raised to z is 1 plus z square by 2 factorial, z cube by 3 factorial plus etc. This is the expansion of e raised to z. So use this expansion for e raised to z minus 1, that is 1 plus z minus 1 plus z minus 1 all square by 2 factorial plus z minus 1 all cube by 3 factorial plus etc. Now this is equal to e into 1 by z minus 1 all square plus z minus 1 by z minus 1 all square. 1 z minus 1 cancel each other, which is 1 by z minus 1 plus this is 1 by 2 factorial plus z minus 1 divided by 3 factorial plus etc. So this is e series n is equal to 0 to infinity. We have the 1 by z minus 1 all square and also negative term. This is z minus 1 power minus 1 and this is z minus 1 power minus 2. So start with the z minus 1 all raised to n minus 2. So that if you put n is equal to 0, first term become 1 by z minus 1 square, that is z minus 1 all raised to minus 2, which is 1 by z minus 1 square. So start with n is equal to 0 and the series is z minus 1 all raised to n minus 2, and here also divided by the factorial n minus 2, n factorial is enough, n factorial. That means first term 0 factorial, that is 1. And second term 1 factorial, that also 1. And third term is 2 factorial. That means n is equal to 0, 1, 2. 2 factorial. Then 3 factorial, etc. So this is the series e into exponential e into, this is e raised to 1. Series n is equal to 0 to infinity z minus 1 by z minus 1 all raised to n minus 2 by n factorial, and this is valid for mod z minus 1 greater than 0. And we can take mod z minus 1 0 less than mod z minus 1 less than 2 and less than 3. If mod z minus 1 greater than 0, this is valid since z is equal to 1 is our singularity and we take it as one centered series. So we want to remove this 1 from our region. So take mod z minus 1 greater than 0. This is valid for these regions.